This video is on polynomial functions and their compositions. A polynomial function is defined as such. Essentially, it is a polynomial where you can input x with any number. Notice that because of the way that a polynomial function is set up, you can input any real number for x, therefore the domain of a polynomial function is all real numbers. Therefore, we can take any real number and input it into our function. So let's take a look at evaluating a polynomial function. So this tells us that we want to input -1 for function f. This would mean that we take each input position of where x was and replace it with what the function is instructing us to do. So we replace all the x components with -1 and we evaluate. So here you need your order of operations. Similarly, you can try the next one. What if our input is just an x? Well, we need to take this component here, f of x, and keep it as it was. And then this is instructing us to multiply everything by 2. Further, here, it's telling us to still replace our function with an x, but then take that whole thing and subtract 5 from it. So we take our function and subtract 5, but when we evaluate, we're just left with -2x squared minus x. Let's take the next one over here because I think we need a little more room for this one. Here we're taking a plus 1 and replacing it for every x that we see in our function. That is what this tells us to do. So we're taking -2 times whatever x is squared minus x plus 5. Our x has now become a plus 1, so we input a plus 1. Now you need to be very careful when you compute this or simplify this because there are some order of operation issues that we need to pay attention to. So here, notice that when there's a plus or minus, you have more than one term, squaring, you cannot take each term and just square it because you're taking a plus 1 and squaring it, meaning it's going a plus 1 times a plus 1. So to do that, we need some distribution. So let's do the inside first here. We get a squared plus a plus 1. And then minus 1 times a minus 1 times 1. Let's collect our like terms. And there we get our answer. So as you can see, you can do various things with polynomial functions. In particular, you can add and subtract the polynomial functions. And here's the definition for adding and subtracting polynomial functions. So for a sum of polynomial functions, it would be written like this, but it would actually mean to do this. Similarly, for a difference, it would be written like this, but it would mean to do this. So let's try it out. Here we have other functions. Notice they're not called f functions, they're called p and s. The letter can be anything, but sometimes the letters are different to signify different functions. So here they say take p and s and add them together. So by definition, this particular piece literally means p of 3 plus s of 3. Now you can find p of 3 and s of 3 and add them. So p of 3 would be the p function evaluated at 3, and s of 3 would be the s function evaluated at 3. So you've got 6 minus 1, and then you've got 9 plus 6 minus 1. So that's 5 plus 14, which is 19. Now, what if we took s plus p of x? We'd have s of x plus p of x by definition, which gives us x squared plus 2x minus 1 plus 2x minus 1. In this case, the plus won't affect any changes in sign, so we don't need brackets. And we always collect like terms, leaving us with x squared plus 4x minus 2. In this next example, we have s minus p, so we're taking s of negative 1 and subtracting p of negative 1. Here, because of the negative, we need to have brackets. So s of negative 1 is going to be negative 1 squared plus 2 times negative 1 minus 1 minus p of negative 1, which comes from 2 times the input minus 1, which the input is negative 1 as well. And so be really careful with using little brackets for your variables, especially when you have a negative sign. The order of operations are going to be impacted that way. So here we've got 1 minus 2 minus 1 minus, in brackets, negative 2 minus 1. So we need to complete the brackets first. 1 minus 2 is negative 1, minus 1 will be negative 2, minus, in brackets, negative 2 minus 1, which is negative 3, leaving us with negative 2 plus 3, which is 1. Finally, we have p minus s of a, which implies p of a minus s of a. Because of the minus, again, we need those brackets. So p of a would be 2a minus 1. S of a would be, in brackets, a squared plus 2a minus 1. And now to compute that and simplify it, we can expand our brackets, giving us negative a squared minus 2a plus 1, combine like terms, and preferably you would leave your answer with the highest exponent going first, so decreasing exponential order. So that would be negative a squared, 2a minus 2a becomes 0, and 1 minus 1 becomes 0 as well. So our final answer is just negative a squared. Further, other than adding and subtracting polynomial functions, we can compose them. This means one goes into the other. So if we have function f, which brings, say, an input x to becoming f of x, so that's function f, then we could take that now as an input for function g, which then you'd have g taken of f of x. So your original x is transformed by two rules, one within the other. So the total is referred to as g of f. The little circle stands for of, and you could have any two functions composed within each other. This is now a new function. It could be called something like h. So in this definition here, we define the composition as g of f of x when you take f of x as an input of g. So let's try that with a few examples. G of f of 2 means take g of f of 2. This means we have to start from the inside and complete the f of 2 first. So what is f of 2? Well, we need to find f of 2 by using the function f. What f does to 2 is multiplies it by 3 and subtracts 2. That gives us 6 minus 2, which is 4. And therefore, now we can put that into g, which then gives us 4 squared plus 1, which is 16 plus 1, which is 17. What if this was written the other way? F of g of 2. Would it be the same thing, do you think? Let's try it out. Now, g of 2 is the input for f. So we have to complete g of 2 first. G of 2 is 2 squared plus 1, which is 4 plus 1, which is 5. So now that means we're going to take 5 and put it into the function f, which is 15 minus 2, which is 13. Now let's see what happens if we use x. So this is translated as g of f of x, which means f of x is 3x minus 2, and that is now our input for our x squared plus 1. So that is 3x minus 2 squared plus 1. Now you would expand that, and you would get 9x squared minus 12x plus 4 plus 1, which then becomes plus 5. You could do the same thing with f of g of x. Now, g of x is the input for f. So you've got f of x squared plus 1. X squared plus 1 is going inside of f, which means we take 3 times x squared plus 1 minus 2 according to the rule determined by f. So we get 3x squared plus 3 minus 2, which is 3x squared plus 1. Let's try these other ones. Here you could compose a function with itself. So this translates, using the definition again, f of 0, which means we have to find f of 0 first and use that as an input for f again. So let's find f of 0. That's 3 times 0 minus 2, which is 0 minus 2, which is negative 2. But now that is our new input, and that takes us to 3 times negative 2 minus 2, which is negative 6 minus 2, which is negative 8. So in general, what happens if we compose f with an x, a random number? Well, that would be, by definition, f of x, which means in f, our input is 3x minus 2. So we're taking 3 times 3x minus 2 minus 2, and when we simplify that, we get 9x minus 8. Finally, let's try this last question. This would be g of negative 1. So first find g of negative 1, which is negative 1 squared plus 1. So that's 1 plus 1, which is 2. And now you have to find g of 2, which is 2 squared plus 1, which is 4 plus 1, which is 5. Here's a written example of composition of functions. An oil well is leaking, with the leak spreading oil over the surface as a circle. At any time t in minutes after the beginning of the leak, the radius of the circle oil slick on the surface is 4 times the time in feet. There's also an area formula of pi r squared to represent the area of a circle based on the radius. So find and interpret A of R of t. So let's expand that by definition. That means take A with an input of R of t. What does that mean? Well, what does R of t mean? R of t meant the amount of feet after t minutes. In fact, it is the radius that this is describing. So for A, the function A means find the area formula given the radius. So if we take the radius, the amount of feet after t minutes in radius, square it and multiply by pi, we'll get the area of the circle. So let's find that formula. Well, that'll be A of 4t, which then will be pi 4t squared. So that's pi times 16 times t squared. That can be written as 16 pi t squared. So what does this formula represent? Well, this formula represents the area of oil after t minutes.